How do reusable rockets manage propellant for landing? Imagine a rocket coming back from space, ready to land safely on Earth. How does it manage its fuel to pull off such a tricky maneuver? Well, it all starts with careful planning and smart engineering. When a reusable rocket prepares to land, it sets aside a special portion of its fuel just for the descent. This reserved fuel is kept separate from what's needed for the main mission. During the landing process, the rocket performs a series of controlled engine burns. These burns slow it down, change its direction, and help it land softly. The first step is the boostback burn. After the rocket separates from the upper stage, it ignites its engines again to reverse some of its horizontal speed and head back toward the landing site. This burn uses up part of the reserved fuel. Next, as the rocket re-enters the atmosphere, it does a re-entry burn. This reduces its speed and helps it survive the heat and stress caused by passing through the thick air. Just before touchdown, the rocket performs a final landing burn. This burn slows it down enough so it can land gently on the ground or a floating platform. To make all this happen, reusable rockets use engines that can be restarted multiple times during the same flight. Their fuel tanks are designed to keep the fuel stable and prevent shifting, which could cause engine problems. The rockets also have attitude control systems. These include small fins called grid fins and engine gimbaling, which is when the engines tilt to steer the rocket. These help keep the rocket stable and pointing in the right direction during descent. Guidance systems are constantly watching the rocket's altitude, speed, and environmental conditions. The onboard computers process this data and make real-time adjustments to engine thrust and control surfaces. This precise control makes sure the reserved propellant is used efficiently and the rocket lands safely. Because carrying extra fuel and hardware adds weight, reusable rockets usually carry slightly less payload than traditional rockets. But the ability to recover and reuse the first stage saves money and resources over many launches. In short, reusable rockets manage propellant for landing by reserving fuel for multiple engine burns, using engines that can restart, and employing advanced control systems. This combination allows the rocket to return safely, ready to be refurbished and launched again.